Hello there and welcome back to the Sleep Science channel, where tonight you're not dozing off to the usual cozy rain or crackling fireplace. No, tonight you're floating with me into deep space, into the velvet silence that even your dreams can't quite capture. Imagine lying on your back in a quiet field, and the night sky isn't just pinpricked with stars but lit by a golden flower opening hundreds of thousands of kilometers away, the James Webb Space Telescope. Its mirrors catch the faintest whispers of light from galaxies that burned before Earth was more than dust. It feels almost too big, doesn't it? Like a bedtime story that might accidentally swallow you whole. And, here's the cheeky bit, you probably won't survive this if you try it without a spacesuit. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're watching from and what time it is there. I love knowing our little constellation of listeners across the globe. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You hover near a machine that looks equal parts alien and delicate origami. Each hexagonal segment of its honey-golden mirror gleams, stretched wider than a tennis court. These pieces unfolded in silence, like the petals of a metallic sunflower, while the rest of humanity crossed fingers and held collective breath. You feel the tension, remembering how easily something could have gone wrong. One jammed hinge, one frozen wire, and billions of dollars of hope would have turned into one very expensive space kite. The James Webb Space Telescope, or JWST because it likes to sound like a boy band, is humanity's most ambitious eye on the universe. A successor to Hubble's stalwart vision. You can almost hear the echo of 1990 when the Hubble launched, blurry-eyed thanks to a flawed mirror. Back then, astronauts had to put on space mechanic gloves and fix it in orbit, turning embarrassment into triumph. JWST, though, is too far for such repairs. Once launched in 2021, it was on a one-way trip. If its vision blurred, we'd just shrug and call it modern art. That risk gives the whole thing a fragile poetry. You're staring at something designed to survive 30 years, yet permanently vulnerable. The telescope doesn't orbit Earth the way the International Space Station does. Instead, it sails in a strange pocket of gravitational balance called Lagrange Point 2. At nearly 1 million miles from Earth, it's not quite tethered, not quite free. Imagine hanging in a hammock stretched between Earth and Sun, gravity gently tugging from both sides. That's where JWST rests, shielded by a 5-layer sunshield the size of a house. Each layer thinner than a human hair, it keeps the telescope so cold that molecules inside practically freeze from shyness. Historians still argue whether we'll remember this decade for its political chaos, or for that golden mirror unblinking into eternity. Either way, in the hush of this story, you see a machine carrying the torch of every ancient astronomer who once squinted at stars with nothing more than polished glass. You recall Galileo peering through his clumsy tube in 1609, shocking Europe by spotting moons circling Jupiter instead of Earth. His telescope was less than 1 meter long, yet it caused scandal. And now, centuries later, we've built a telescope whose mirror stretches 6.5 meters across, whose tube is the size of a school bus, and whose scandal is that it may show us a universe stranger than we're prepared for. Here's the quirky tidbit for your pillow talk. JWST isn't just coated in gold for style points, though it does look like space jewelry. That gold is only a few atoms thick, less than the width of a red blood cell, yet it makes the mirror superb at reflecting infrared light. Basically, it's bling with purpose, and without it, those faint stretched whispers of ancient starlight would vanish into black. You float closer, tracing the seams between the 18 golden petals. Each one was ground with a precision so fine that if you scaled the mirror to the size of North America, the bumps would be smaller than an ant. That's the kind of obsessive detail work that makes you either awestruck or very tired, depending on how much coffee you've had. Humans built this eye not only to look outward, but backward, through time itself. You sense a kind of hum, though in space there's no sound, of course. It's the hum of data flowing back toward Earth, laser-beamed in tight, invisible pulses, carrying photographs you'll eventually scroll past on Twitter with a shrug. But here, before the shrug, before the meme, is the raw astonishment of photons that left their galaxies before dinosaurs grew feathers, now captured by a mirror finer than anything nature ever shaped on its own. You might chuckle to yourself, because while JWST cost about $10 billion, that's less than what humanity spends on coffee in a year. So in a way, It's just one giant frappuccino we sent into orbit. But unlike your daily caffeine fix, this telescope shows us that galaxies once thought to form slowly are popping up alarmingly fast in its deep-field images. We'll get to that shock later, but for now you linger in this first encounter, standing on the edge of human ingenuity, balanced between terror and wonder. You can't shake the thought that this golden eye is as fragile as a butterfly wing and yet as ambitious as the pyramids. In fact, here's a mainstream fact to lull you. The Great Pyramid of Giza took roughly 20 years to build with thousands of labourers. JWST took about 30 years, with armies of scientists and engineers scattered across the globe. Ancient stones versus futuristic mirrors, both monuments to humanity's refusal to accept good enough. A faint joke bubbles up in your tired brain. If JWST were a dating profile, it would read, "Huge golden eyes, loves long walks around the sun. Can see your flaws from 13 billion light years away." Not the most comforting partner, but definitely attentive. And so you hang here with me in the silence, staring at the golden flower that has unfolded against the backdrop of nothing. It's both a machine and a mirror, showing you how far humanity has stretched its imagination, and more importantly, how fragile we still feel when we aim our gaze too deep into the dark. The thought drifts through you like a lullaby. Perhaps we didn't build JWST to see the universe. Perhaps we built it so the universe could see us, tiny creatures daring to polish a mirror and hold it up to infinity. The telescope drifts with you now, far from the warmth of home, anchored at its orbital perch in the cold cradle of L2. The name sounds technical, like a password you'd forget, but the reality is strangely poetic. The second Lagrange point, a hidden equilibrium where Earth and Sun's gravities balance just enough to cradle a spacecraft without constant correction. Imagine dangling a marble on a string between two magnets, suspended in a sweet spot of tension. That's where you float, almost still, yet carried endlessly around the Sun, 1,000,000 miles from Earth. It feels like standing on the back porch of the solar system. Earth is a pale blue bead in the distance, shimmering like something you might accidentally swallow if you weren't careful. The Moon clings nearby, a pearl orbiting its bigger sibling, and then there's you, watching from the far side where the night never ends. You could almost call it cozy, if cozy meant minus 23 degrees Celsius. The silence here is different. Not the silence of a library, not the hush of a bedroom when you're trying to drift off, but a silence so perfect it feels like a physical weight pressing on your ears. JWST thrives in this silence, because the telescope must stay colder than frozen nitrogen to catch faint heat signatures from ancient stars, and its sunshield, a 5-layered silver kite stretched wider than a house, shadows it completely, blocking sunlight, earthlight, even the warmth of the moon. Without this cloak, its mirrors would glow too warmly, drowning out the whispers of galaxies. Historians still argue whether the invention of Lagrange points in celestial mechanics deserves more fame than Newton's laws of motion. After all, Joseph Louis Lagrange, an 18th century mathematician, found these cosmic parking spots by fiddling with equations, not rockets. And yet, centuries later, here we are parking a $10 billion telescope in one of his imaginary notches in space, like sticking a bookmark in the universe. You glance at the telescope and the gold mirror gleams faintly under the perpetual shadow. It looks less like a machine and more like an altar. You can't help but think about the ancient stone circles at places like Stonehenge. People drag giant rocks for miles just to line them up with solstices to mark the heavens in their way. JWST is simply our modern Stonehenge. Except instead of rocks, we built a sunflower of beryllium and gold, and instead of watching midsummer sunset, it peers back to when the first stars sputtered into existence. Here's a quirky tidbit. JWST doesn't need fuel to stay balanced at L2. It just gently sips thrusters now and then to keep from drifting, like a lazy swimmer occasionally flicking their foot to stay in the pool's centre. And because it's in constant shadow, it doesn't deal with day-night temperature swings like satellites closer to Earth. In fact, it's more stable than your Wi-Fi connection. Still, you imagine how lonely it must feel out here. A solitary sentry facing outward into eternity. It can't look back at Earth. Its instruments are designed for the dark, so the brightness of home would blind it. You picture a child who's told not to stare at the sun, dutifully keeping their gaze elsewhere. JWST obeys, always looking away, always turning its golden face to the unknown. If you stretch your imagination, you can almost hear the faint shush of solar wind brushing against the shield. Not that it makes a sound, but your dreaming mind fills in the hush anyway. Around you is the cosmic background radiation, the afterglow of the Big Bang, faint microwaves that have been humming since the universe's first breath. You float inside that lullaby, knowing the telescope's detectors can tease patterns from that near silence. The placement at L2 wasn't just convenience, it was necessity. Hubble orbits Earth every 90 minutes, dipping in and out of daylight, shivering through cycles of heating and cooling. JWST needed serenity, a permanent night sky. The engineers wanted a place where the telescope wouldn't have to squint through the glow of our atmosphere or dodge Earth's glare. Here at L2, it's as if the universe opened a private window just for us. There's something almost mythic about it. Ancient cultures imagined the heavens as layered realms. The Babylonians had 7 skies. The Norse had 9 worlds stacked upon Yggdrasil, the great cosmic tree. L2 could easily fit into those maps, a secret level between Earth and infinity, where mortals dared to park a golden eye. And yet you grin at the irony. This sacred perch is also full of space junk hazards. Dead satellites and random fragments occasionally pass through the L2 neighbourhood, like litter drifting into a cathedral. JWST has already dodged micrometeoroid impacts, tiny space pebbles travelling at blistering speeds. One of them even dented a mirror slightly in 2022, but the telescope shrugged it off, proving sturdier than it looks. The thought settles over you. If JWST is a lighthouse, L2 is its cliff, firm, steady but exposed to storms you can't see, and you, floating beside it, sense the fragile balance of it all. Gravity tugs from the sun, earth and moon, each pull softened by geometry yet always threatening drift. A nudge too strong and the telescope would wander into either furnace or oblivion. It's the cosmic equivalent of trying to nap on a tightrope. You recall a mainstream fact to steady yourself. The telescope launched on December 25, 2021, aboard an Ariane 4 rocket from French Guiana, Christmas Day. While many people unwrapped sweaters and gadgets, engineers unwrapped the most ambitious gift ever sent to the stars. A machine that unfolded like a flower in January 2022, petal by petal, mirror by mirror, humanity's present to itself. You find the humour in it. Santa didn't deliver this one down chimneys. We hurled it into space with a controlled explosion. And unlike most Christmas toys, this one didn't need batteries, just sunlight and physics. From your perch here, you can't shake the feeling that the telescope looks less like a machine and more like a Voyager frozen mid-bow. A knight kneeling at the edge of a cosmic cathedral, shield raised, eyes unblinking. It doesn't pulse or spin dramatically. It simply waits, watching light arrive from galaxies so distant they're practically ghosts. You breathe slowly, you let the silence of L2 fold around you like a blanket. You know the telescope has decades of work ahead, and you too feel the stretch of years. Out here, time seems strange, measured not in hours but in orbits, in photons arriving after billions of years of travel. You are small, the telescope is small, but together, balanced in this quiet pocket of nothing, you feel enormous. You wait with the telescope still cold and silent as its golden eye finally blinks awake. For weeks it had been stretching, flexing, unfolding like an origami bird. Mirrors aligned with a precision so absurd you could compare it to hitting a golf ball in Los Angeles and landing it inside a teacup in Tokyo. Engineers on Earth adjusted each segment one microscopic nudge at a time, using laser beams and algorithms until the honeycomb reflected as one flawless mirror. And then, after years of anticipation and sleepless nights, the phrase finally came across the NASA feed. First light. The universe doesn't exactly roll out a red carpet, but that first image felt close. You lean in and watch galaxies bloom across the black, and not a handful, not dozens, but thousands, each one a city of stars so distant their light had to run a relay race across 13 billion years to reach us. They spill across the frame like gems scattered on velvet, spirals, ellipses, glowing smudges too faint for Hubble to catch. You blink, but they don't vanish. They were always there, we just lacked the right eyes. Historians still argue whether the printing press or the telescope has done more to shift how humans think about themselves. The press made words immortal, but the telescope made Earth small. Galileo caused scandal with his moons of Jupiter, Hubble, the astronomer, not the satellite, proved the universe was expanding, and now JWST is showing us galaxies forming at breakneck speed. Each leap shrinks us further and yet, paradoxically, makes us feel part of something vast. You can almost hear the quiet gasp echoing across history, from medieval monks to TikTok teens. What you're seeing isn't just pretty wallpaper, it's a time machine snapshot. Some of those galaxies existed only a few 100 million years after the Big Bang, a blink in cosmic terms. Astronomers expected fuzzy baby galaxies, awkward cosmic toddlers. Instead, JWST handed over galaxies that looked suspiciously grown up, large, structured, and already shining brightly. Imagine expecting a newborn and getting a teenager who asks for car keys. No wonder scientists nearly spit out their coffee. You try to take it in, but your mind wanders to a quirky tidbit. The first deep field image, released in July 22, wasn't just about the galaxies. Hidden in the photo were arcs and smears created by gravitational lensing. Massive galaxy clusters bent space-time itself, magnifying background galaxies like a cosmic magnifying glass. It was Einstein's theory of general relativity casually doodling across the photograph. He'd predicted this over a century ago, and now you're seeing it. Space bent. Light curved, reality stretched like taffy. You wonder how absurd this must feel for the astronomers watching live. Decades of planning, billions of dollars, years of nail-biting deployment, and suddenly it works. Not just kind of works, but jaw-droppingly, record-breakingly works. You imagine a room of exhausted scientists collapsing into their chairs, weeping with joy, probably ordering pizza because what else do you do after catching galaxies being born? The first light moment has its roots in history too. Back in 1990, Hubble's first light was a disappointment. Images came back blurry because its mirror was ground incorrectly. A flaw thinner than a strand of hair ruined clarity until astronauts fixed it in 1993. JWST couldn't be repaired, remember? If its first images had been blurry, the whole mission might have been considered a failure. The relief when crisp galaxies popped onto the screens must have been palpable, like realizing your souffle actually rose in front of the entire dinner party. And because I promised 3 gentle jokes per section, you catch yourself thinking the telescope is basically the world's most expensive influencer ring light. Except instead of making TikToks, it casually photographs the dawn of time. Also, if galaxies were dating profiles, JWST is exposing how many of them lied about their age. And finally, consider that the first deep field was released by President Joe Biden himself. Imagine explaining to someone in the 1800s, yes, the leader of a country will one day hold up a photo of galaxies billions of light years away as a political milestone. That's the kind of plot twist historians drool over. You let your eyes wander across the image again. Each glowing smudge is a galaxy. Each galaxy is billions of stars. Around many of those stars, planets may orbit. Around some of those planets, life might stir. The scale is dizzying, and you feel your body almost tilt forward, as if gravity itself wants to pull you into the frame. You steady yourself, breathing slowly, letting the enormity wash over you like a tide. The telescope hums faintly in your imagination, and you picture the data streaming back, encoded light, translated by computers into colors your eyes can handle. Infrared photons, invisible on their own, reborn as reds, blues and golds. It's not a lie, it's an interpretation, a translation, like turning whale songs into sheet music. The universe is singing, and JWST is handing us the score. You remember too that this isn't the end but the beginning. These first images were proof of concept, a promise that the telescope could see what it was built for, but tucked inside them were already hints of puzzles. Galaxies too big, too old, too soon. A cosmic timeline fraying at the edges. Theories muttering to themselves nervously. You can almost hear the whisper, what if our models are wrong? And maybe that's why the first light feels so electric. Not just because it works, but because it rattles us. It says, everything you thought you knew about the early universe might need revising. That the universe is stranger, faster, more ambitious than we ever dared to dream. You let that thought settle into you, slow and heavy like a warm blanket on a cold night. Out here, balanced at L2, staring at galaxies from the dawn of time, you realize you're not just a spectator. You're part of a species that dared to build a golden eye, aimed it into the dark and gasped at what it found. And maybe that gasp, the collective inhale of wonder, is the truest first light of all. You're still floating beside the telescope, but now the images that pour through its instruments start to tangle in your mind. You'd expected to see fuzzy blobs of early galaxies, messy clusters of newborn stars still learning how to shine. Instead, JWST shows you something unsettling. Galaxies that appear fully formed, bright, massive, and suspiciously mature, existing when the universe was just a few 100 million years old. It's like opening a baby photo album only to find your infant already has a mortgage and a receding hairline. The shock ripples through the scientific community. For decades, cosmology has worked with a neat timeline. Big Bang, Dark Ages, first stars flickering, galaxies gradually clumping together. It was a well-ordered bedtime story, reassuring in its rhythm. And then Webb looked too deep too soon and the story cracked. Suddenly, you're assembling at massive galaxies 10 times more massive than models predicted, living in an era when the universe should still have been stretching and yawning. Astronomers blinked, rubbed their eyes, and double-checked the calibration. But no, the light was real. Historians still argue whether moments like this, when evidence undermines cherished theories, are terrifying or thrilling. Think of Copernicus suggesting Earth wasn't the centre of everything, or Darwin sketching his messy tree of life. Each revelation caused us chaos before becoming common sense. Now JWST threatens to rewrite the opening chapters of cosmic history. Were galaxies forming faster than we thought? Did gravity pull matter together with more enthusiasm, or is something even stranger hiding in the data? The mainstream fact is this: galaxies we see today, like the Milky Way, took billions of years to assemble their spirals. Early galaxies should have been dim smudges, not radiant cities of stars. Yet JWST caught some that existed just 300 million years after the Big Bang, already bustling. To put that in perspective, if the universe's 13.8 billion year history were a single calendar year, these galaxies would have appeared in the first few days of January, already acting like it was mid-March. And here's a quirky tidbit to rest your head on. Astronomers jokingly call these impossible galaxies. It's a nickname whispered in conferences, half serious, half panicked. Nobody likes it when the universe breaks the syllabus. Some even wondered aloud if the telescope was too good, showing details we weren't ready to handle. Imagine asking your child to whisper a bedtime story and instead they recite Shakespeare flawlessly. It's impressive, but also unsettling. You glance at one of the deep field images again, and you notice the colours. Some galaxies gleam red, stretched by cosmic expansion. Others shine blue, still hot from starbirth. The oldest ones glow faintly, barely visible, yet undeniable. You realise each smudge is a challenge hurled at physics textbooks. It's as though the cosmos is smirking, whispering, "Thought you had me figured out? Try again." Your mind drifts to earlier surprises in astronomy. When Edwin Hubble proved galaxies were moving away, it implied the universe itself was expanding, a radical idea in the 1920s. Many scientists resisted, clinging to the comfort of a static cosmos. Now, a century later, Webb might be nudging us toward an equally uncomfortable revision. Theories that galaxies should form slowly, growing through collisions and mergers, might need rewriting. Perhaps matter was denser than expected in the early universe. Perhaps dark matter behaved differently. Perhaps we're missing something big. You chuckle softly at the thought. Humans finally build an instrument that can look back to cosmic dawn, and the universe responds by flipping the script. It's like studying diligently for a test, only to discover the exam is written in another language. But there's humour in the disorientation too, astronomers muttering into their coffee cups, joking that the universe owes them an apology. 3 small jokes slip in as you drift. Maybe the galaxies were just overachievers, the honour students of the early universe. Or maybe they're cosmic influencers, desperate to glow brightly before anyone else. Or, my favourite, perhaps JWST just embarrassed the Milky Way, revealing that other galaxies managed to get their act together faster than ours. You settle back into the hum of silence, but your thoughts are restless. Each new paper published in the wake of these discoveries feels like a whisper from the telescope itself. Look closer, question harder. Some scientists argue the galaxies might not be as massive as they seem. That light can be tricky, distance is deceptive. Others believe we're on the cusp of revising the timeline of cosmic dawn altogether. The debates are fierce but tinged with wonder, like children arguing about the rules of a game they've just invented. You imagine future textbooks, illustrations redrawn to match Webb's revelations. The neat diagrams of gradual galaxy growth replaced with messy explosions of star formation, sudden surges of brilliance in the darkness. Maybe you think the universe wasn't patient. Maybe it raced ahead, bursting with urgency, unwilling to wait. The telescope hovers silently, golden petals glimmering against infinite black. It doesn't offer explanations, only more questions. You realize that's the real shock, not the galaxies themselves, but the reminder that every answer spawns 10 new mysteries. It's the same shock Galileo felt, the same Copernican dizziness, the same Darwinian awe. The cosmos never fits the box we make for it. And as you drift, lulled by the weight of those galaxies burning too soon, you find comfort in the thought. If the universe insists on surprising us, maybe that's its way of keeping us awake. Or, paradoxically, maybe it's the perfect bedtime story, a tale without neat endings, only infinite beginnings glowing far beyond the edge of sleep. You linger on those impossibly early galaxies, but your gaze begins to soften, drawn toward the faintest glimmers, threads of light stretched thin across space and time. These are not ordinary beams, they are survivors. Photons born billions of years ago, in stars that burned out before Earth had even coalesced, now drift like ghostly travellers into JWST's golden mirror. By the time they arrive, they are weary, stretched to long wavelengths by the swelling of the universe itself. This is redshift, the cosmological version of a lullaby slowed down until the notes blur together. Imagine you could hold one of those photons in your hand. At its birth, it might have been the blazing blue of a newborn star, but across 13 billion years of running through expanding space, its energy thinned, its wavelength elongated, until it reached us as a faint infrared whisper. JWST was built precisely to catch these tired travellers, light too long, too faded for Hubble to see. In this way, the telescope is less a camera than a time capsule reader, gently coaxing ancient messages out of silence. Historians still argue whether humanity's obsession with light, candles, lighthouses, telescopes, is more practical or spiritual. Was it about survival or about meaning? You smile at the thought that firelight once gathered tribes in caves, and now, much later, starlight gathers us online, marvelling at cosmic selfies released by a space telescope. Same instinct, different campfire. Here's the mainstream fact that steadies you. The universe is 13.8 billion years old, and the furthest light JWST has detected so far dates to around 13.5 billion years ago. That means you're essentially looking at the universe when it was less than 300 million years old, an infant cosmos. To phrase it differently, if cosmic history were a novel, Webb has begun flipping back to the first chapter where the ink is still wet, and here's your quirky tidbit. Some of the earliest photons JWST detects actually began their journey before the Milky Way even existed. Think about that for a moment. These particles of light travelled the void long before our galaxy formed, before the sun lit up, before Earth hardened. They've been en route for longer than our planet has had oceans, continents, or even happened dust. You're not just looking at stars, you're looking at endurance. The telescope's instruments translate these stretched wavelengths into colour images your eyes can appreciate. You know they're false colours, but false doesn't mean fake. They're interpretive, a way to make the invisible visible. It's like giving music notes to someone who can't hear, or describing a scent in words. The translation may not be literal, but it carries truth. You can almost feel the warmth of those stars, even though their light has cooled into infrared ghosts. You picture the universe expanding during that journey. Galaxies drifting apart, space itself ballooning, dragging light into longer wavelengths like a rubber band stretched until it thins. Cosmologists call it the cosmological redshift. It's not that the light slowed down, it's that space itself grew between the photon's footsteps. Imagine running on a treadmill where the belt keeps stretching longer under your feet. You never stop running, but the finish line keeps receding. That's the photon's fate. And because you promised yourself 3 light jokes per section, here they are. First, you realise these photons travelled billions of years just to end up in a NASA press release. Talk about anticlimactic. Second, it makes you think the universe is basically a procrastinator, waiting 13 billion years before finally showing up in our telescope. And third, imagine trying to explain redshift to a toddler. Well, Honey, the light is tired because the space itself is getting stretch marks. Still, the beauty of it sinks deeper than jokes. You think about how fragile these signals are. One wrong calibration, one stray satellite, and the whisper might have been lost forever. Yet here you are, drifting with JWST, watching light that carries the fingerprints of the first stars. Some of that light reveals not just brightness, but chemistry, traces of hydrogen, helium, heavier elements and elements forged in nuclear furnaces. The spectrum itself tells stories of creation. You recall how in the 65 feet, Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background, the faint hiss of the Big Bang. They thought at first it was pigeon droppings in their radio antenna. Now, decades later, JWST is catching not just the hiss, but the music layered above it, the first harmonies of stars and galaxies. Historians still marvel at how often discovery begins with a mistake, a noise, a puzzle. Perhaps JWST's 2 early galaxies will one day be reinterpreted as another happy accident in our long, messy quest to know. You exhale, and the thought slows you. These photons are fragile, yet here they are, preserved against every odds. It's humbling, isn't it? You worry about emails being lost after a decade, yet light has travelled billions of years intact. You find yourself whispering thanks to the cosmos, as though the stars could hear your gratitude retroactively. And as you gaze at the endless redshifted glow, you realise that JWST doesn't just show us the past. It shows us the persistence of memory on a universal scale. Every beam of light is a testimony. I was here, I burned, I mattered. And you, floating quietly beside this golden mirror, become the witness, the reader of a story written in photons. You close your eyes for a moment, but the glow lingers inside them. The thought hums through your bones. We are built of the same atoms that once shone as light, now return to stare back at their own reflection. Perhaps that's the real redshift, the stretching of self across time, reaching from the dawn of stars to the present moment, whispering you into sleep. Your drifting mind now turns from the faint whispers of ancient galaxies to the fiery cradles where stars are still being born. JWST, with its golden petals tuned to the infrared, has peeled back veils of dust and gas that once obscured the most dramatic nurseries in the sky. Places like the Carina Nebula and the Orion Nebula, familiar to backyard stargazers as glowing patches, suddenly burst alive in intricate detail. Instead of distant fog, you see walls of gas sculpted into towering cliffs, cosmic valleys and cavernous hollows where gravity tugs material inward, coaxing new suns into existence. It's like walking into a delivery room for the cosmos, only the babies weigh millions of times more than Earth. The Carina Nebula in particular feels like the crown jewel of Webb's early portraits. You watch it unfold across the telescope's detectors, jagged mountains of dust glowing in hues of amber and sapphire, light years tall, shaped by the blast of nearby massive stars. This place is less nursery and more wild playground, intense radiation carving pillars and bubbles, winds shredding filaments, stars punching holes through their wombs as soon as they ignite. It is violent, yes, but also breathtaking. You sense the paradox, creation and destruction intertwined, beauty born from chaos. Historians still argue whether the invention of photography in the 1800s prepared humanity for this kind of revelation. Early photographs made faces permanent, landscapes timeless. But astrophotography, pioneered by John Draper in 1840 when he captured the moon, made the unseen visible. Without that lineage of lenses and emulsions, perhaps we wouldn't have been ready for Webb's portraits of stellar birth. And yet here we are, eyes wide, scrolling past 1,000-year cosmic drama on our phones between cat memes. The mainstream fact grounding you is this: stars are born when dense pockets of gas collapse under gravity, heating until nuclear fusion ignites. Fusion turns hydrogen into helium, releasing light and energy, a process that can last billions of years depending on the star's mass. Nebulae are essentially star factories, recycling material from earlier generations of exploded suns. In Carina, Orion, and countless other regions, Webb reveals that process in progress, catching stars mid-birth like candid photographs of infants taking their first breath. And here's your quirky tidbit: the Orion Nebula, so often drawn as a mystical backdrop in science fiction posters, is close enough that if your eyes were tuned to infrared like JWST, It would glow so brightly in the night sky that it could cast shadows on Earth. Imagine children playing under Orion's shadow instead of moonlight. It's a thought that makes you grin at the absurdity of our limited senses. You hover deeper into these images, tracing tendrils of gas where protostars hide. Some are surrounded by disks of dust, embryonic planets already forming in the shadows. You realize you're watching the same process that once built the sun, the earth, and the ground you sleep on each night. Stardust isn't just a poetic metaphor. It's your origin story being replayed in living color. You're seeing the childhood of suns that might someday host their own constellations of life. The telescope's infrared vision is key here. Dust clouds that block visible light glow gently in the infrared, revealing layers beneath the shroud. Hubble could see the outlines, but Webb opens the curtains, exposing structures never glimpsed before. You watch jets of material spew from newborn stars, streams of energy carving the surrounding gas like fire hoses in slow motion. These jets are signals, announcements that fusion has begun, that another star has joined the galactic chorus. And yes, 3 gentle jokes drift in with the cosmic dust. First, nebulae are basically the universe's messy bedrooms, where stars leave their stuff scattered everywhere before tidying up into neat solar system. Second, the Carina Nebula's pillars are nicknamed cosmic cliffs, but honestly, they look more like cotton candy that's been dropped in a campfire. And third, you can't help but think astronomers get paid to do the ultimate baby photo shoots, except their babies weigh several million Jupiters and throw tantrums made of plasma. Still, beneath the playfulness, you sense something profound. These nurseries aren't just picturesque. They're reminders that the cosmos is still alive, still creating. When you look up at Orion's belt on a winter night, you're not just seeing stars, you're glimpsing an active construction site where future generations of light and planets are being assembled. It's the ultimate continuity. Stars die, scattering their ashes, which gather into clouds, which collapse into new stars, which eventually scatter again. You remember too how cultures once looked at Orion and Carina with their own interpretations. Ancient Egyptians saw Osiris in Orion, a god of rebirth. The Maori of New Zealand called the Carina Nebula part of Te Waka, Otama Rarity, the canoe of a celestial navigator. Long before telescopes, people intuited these regions as sacred sites of birth and renewal. Webb doesn't erase those stories, it deepens them, layering science atop myth until both resonate. You lean back, letting the image of Carina's cosmic cliffs linger. They stand taller than Everest, glowing in colours invisible to naked eyes, alive with storms that will rage for millions of years, and yet here you are, watching them tonight, folding their scale into your sleepy imagination. The telescope doesn't just show you stars being born, it reminds you that creation is always ongoing, always hidden in the folds, waiting for the right eyes to seize. And maybe that's why these nurseries feel so comforting. They whisper that endings aren't really endings, that death begets birth, that ashes bloom into suns. As you let that thought cradle you, the violent beauty of Carina becomes strangely gentle, a lullaby written in hydrogen, echoing softly across the darkness. You drift onward with the telescope, leaving behind the nebula where suns ignite, and turn your gaze towards something even more intimate, the skies of other worlds. For centuries, humanity wondered whether planets beyond our solar system even existed. Now, not only do we know of thousands, but JWST has begun to taste their atmospheres, sniffing their chemical perfume from light years away. It feels almost like leaning in close to an alien garden and catching the faint scent of water, methane, or clouds of metal. You shiver a little, realizing this golden mirror is the closest thing we've built to an interstellar weather vane. The method is deceptively simple in description, though absurdly complex in practice. When a planet passes in front of its star, starlight filters through its atmosphere before reaching JWST. Certain wavelengths are absorbed by molecules, leaving behind fingerprints in the spectrum. By spreading the light into a rainbow and measuring tiny dips, scientists can tell whether water vapor, carbon dioxide, or methane are present. It's like reading a secret diary written in sunlight. And JWST's instruments are so sensitive that they can detect these fingerprints even when the planet is nothing more than a shadow across a distant star. Historians still argue whether the Copernican revolution, or the discovery of exoplanets, marks the bigger blow to human self-importance. First, we learned Earth wasn't the centre of the universe. Now we learn Earth isn't even rare. As of today, astronomers have catalogued over 5,000 confirmed exoplanets, and JWST is poised to tell us which of them have skies, seas, maybe even weather that echoes our own. The mainstream fact is that in 2022, JWST studied the hot gas giant WSP-96b, a bloated planet larger than Jupiter. It detected clear signs of water vapor in its atmosphere. Water on a world too hot to host oceans, but proof nonetheless that the telescope's sniffing trick works. Later, Webb turned its gaze to WSP-39b, another inflated giant, and found carbon dioxide for the first time ever in an exoplanet atmosphere. These detections may not sound romantic, no alien cities revealed, but scientifically they're groundbreaking. They show that JWST can map chemistry across light years, turning pinpricks of starlight into tangible places. Here's your quirky tidbit. Astronomers sometimes describe JWST as the galaxy's sommelier. Instead of wine, it samples alien atmospheres, swishing starlight around its instruments and declaring, "Ah yes, strong notes of methane, a hint of cerium, perhaps best paired with a blue-white star." The humour isn't far from the truth. The telescope really does grade atmospheres like vintages. You lean into the data streaming back and imagine those skies yourself. Picture a world where clouds are made of glass, where winds blow at thousands of kilometres per hour, hurling shards sideways in glittering storms, or another planet where it rains liquid iron, droplets falling in slow arcs before splashing into glowing seas. These aren't science fiction flourishes, they're predictions based on atmospheric models that JWST now has the power to test. Suddenly, Alien Weather Report doesn't sound like a joke, it sounds like tomorrow's headline. And because you promised yourself 3 gentle jokes, first, you realise that if JWST were alive, it would have the worst allergies in the universe, sniffing atmospheres constantly. Second, you can't help but imagine a future weather app that casually announces storms of molten quartz expected on Kepler 7b, pack accordingly. And third, you note that JWST has already done what every romantic comedy protagonist dreams of, reading the atmosphere perfectly. Still, you sense the deeper stakes here. Water vapor, carbon dioxide, methane, these aren't just gases, they're potential biosignatures. On Earth, life interacts with the atmosphere, shaping its chemistry. If JWST finds a cocktail of gases that look suspiciously like biology, the implications ripple far beyond astronomy. It would mean we're not alone, that somewhere out there, beneath alien skies, something breathes. Yet scientists tread carefully. Historians still debate whether claims of Martian canals in the 19th century slowed or spurred interest in life beyond Earth. Too much hype risks disappointment. Too little risks missing a revolution. So JWST's team speaks in measured tones, cautious not to declare aliens hiding in their data. But you, floating beside the telescope in your sleepy imagination, feel the thrill anyway. You imagine the collective shiver if one day a press release confirms an atmosphere that cannot be explained without life. You think too about how fragile the line is between science and myth. Ancient cultures looked up and filled the skies with gods, dragons, heroes. Now we fill them with spectrographs and spectra, yet the awe feels the same. To know that light, after crossing billions of kilometres, can whisper the recipe of an alien sky, it's magic dressed as physics. As you let that thought stretch, the telescope's golden mirrors glimmer quietly. JWST is patient. It will spend decades collecting these whispers, slowly building a library of alien weather reports. You picture a shelf in some cosmic archive, bottles labelled with exoplanet names, each containing the faint scent of another world's sky. Someday, perhaps, we'll open one and inhale, recognizing something achingly familiar. And that is the lull of this part of the journey. You float among invisible vapours, listening to the universe breathe. Each exoplanet is a sigh, a note, a possibility. The cosmos feels less empty now, more populated, more alive. You tuck that thought under your pillow, that even in the vast dark there are skies waiting to be known. And maybe, just maybe, someone under those skies is looking back. You drift alongside JWST, and now its gaze shifts from quiet planetary skies to the grand theatre of galactic collisions. The telescope's golden eyes catch galaxies in the act of merging, their spirals unravelling, their arms twisted into tidal streams that stretch for tens of thousands of light years. You watch them as if they're dancers caught mid-spin, luminous skirts flaring, stars scattering like sparks from a bonfire. Gravity is both choreographer and demolition crew, pulling galaxies together, shredding and sculpting them at the same time. It feels violent, but it also feels oddly graceful, like a slow-motion waltz set to a rhythm only the cosmos can hear. One image in particular seizes your attention. Stephan's quintet, a cluster of 5 galaxies. 4 of them are locked in a gravitational embrace, their shapes distorted into overlapping spirals and strange arcs. The 5th galaxy, a little farther away, photobombs the scene but still seems part of the drama. JWST's infrared view reveals shockwaves rippling through clouds of gas as these galaxies crash together, compressing matter into bursts of new star formation. It's chaos, but it's also fertile, cosmic collisions that don't just destroy Haboras, but create. The mainstream fact grounding you here is that our own Milky Way is on a collision course with the Andromeda Galaxy. In about 4 billion years, the 2 spirals will meet, intertwine, and eventually merge into a single elliptical galaxy. By then, Earth may no longer host a life, but the sky will blaze with extraordinary displays, ribbons of stars arcing across the horizon. When you look at Stephan's quintet, you're seeing our future written in someone else's present. Historians still argue whether galaxies are best understood as dynamic systems or as snapshots frozen in time. For much of the 20th century, astronomers assumed galaxies evolved slowly and predictably, but images from telescopes like Hubble, and now Webb, reveal that collisions are common, even essential to galactic evolution. Galaxies grow by swallowing one another. It's not neat or polite, it's a cosmic buffet where the main course is always other galaxies. Here's your quirky tidbit. The soundtrack to Stephan's quintet once went viral. Scientists converted its light into sound, turning JWST's data into eerie harmonies, celestial music born from gravitational chaos. You can imagine yourself floating there, listening to a galactic choir humming in infrared. It's not accurate in the sense of real sound, since space is silent, but it gives you goosebumps anyway. The scale of it overwhelms you. Each galaxy contains hundreds of billions of stars. Each star may have planets, and here they are, colliding like billiard balls across millions of light years. To your sleepy imagination, it feels absurd, like 2 oceans colliding, each wave holding entire civilizations. Yet gravity is patient, stretching these collisions over hundreds of millions of years. What looks like an explosive crash in a still image is, in reality, more like a very long, slow embrace. You let a few playful jokes bubble up to soften the awe. First, you think galactic collisions are basically the universe's way of saying you up to its neighbours. Second, Stephan's quintet is technically 4 galaxies colliding and 1 tagging along, so maybe it should be called Stephan's awkward double date. And third, if galaxies were people, collisions would be their version of networking events. Messy, loud, and somehow everyone comes out bigger afterward. Still, you can't shake the gravity, literally, of what you're watching. These aren't accidents, they're a part of the design. Collisions compress gas into dense regions, triggering waves of star formation. New suns flare into life because galaxies rammed into each other. Destruction births creation again, echoing the cycle you saw in nebulae, only now on a grander, more terrifying scale. You think about how ancient cultures might have imagined this if they could see it. To the Maya, perhaps it would have looked like sky serpents twining. To the Greeks, maybe the clash of titans, their luminous bodies smashing and scattering sparks. To us, it's physics, gravity shaping matter, but the poetry isn't lost. Webb's images straddle both science and myth, carrying the same awe that once made shepherds and sailors map the heavens in story. The telescope hums on, catching more of these tangled galaxies. Some show clear tidal tails, vast streams of stars flung out into intergalactic space. Others reveal hidden black holes at their cores, lit up as material falls inward during the chaos. You realise that what you're seeing is not rare, it's the rule. The universe is not a peaceful, static gallery of spirals. It is an arena, a place where galaxies wrestle, merge and transform, endlessly reshaping themselves. And as you drift in this realisation, the strangeness of it turns calming. If even galaxies are temporary, if even their shapes can be torn apart and remade, then your own small transformations don't feel so strange. Change is written into the stars themselves. Collisions are not the end, they are the path forward. You close your eyes, and for a moment you imagine Earth's far future sky. Andromeda rising larger each night, arcs of stars stretching across the horizon, our galaxy colliding in slow motion with another. You won't be here to see it, but JWST lets you dream it anyway. And in that dream, the chaos of cosmic collisions becomes oddly soothing, like a lullaby composed of crashing galaxies sung across the dark. You linger on the colliding galaxies, but your attention is soon drawn to the darker, hungrier hearts of the cosmos, the black holes. JWST, with its uncanny eye for the invisible, has begun to reveal them not as abstract equations, but as blazing engines, devouring matter and shining brighter than entire galaxies. It feels paradoxical, doesn't it? Objects famous for swallowing light becoming some of the brightest beacons in the sky. But that's how quasars work. Gas spiraling into a supermassive black hole heats up and glows so fiercely that it outshines billions of stars combined. You drift closer in imagination, but not too close. You don't want to become part of the menu. One of Webb's early targets was a quasar nearly 13 billion light-years away. That means the black hole powering it had already grown to monstrous size less than 1 billion years after the Big Bang. The mainstream fact here is unsettling. These early quasars suggest black holes can bulk up far faster than models predict. By our current understanding, they shouldn't have had enough time to get that big. Yet there they are, shining defiantly, their accretion disks blazing like lighthouses in primordial seas. Historians still argue whether black holes should be considered discoveries of observation or imagination. For decades they were purely theoretical, solutions to Einstein's equations that seemed almost too bizarre to be real. Even Einstein himself doubted they existed. It wasn't until the 1960s, with the discovery of quasars and X-ray binaries, that black holes moved from mathematics into reality. Now, with JWST, we're seeing them not just in our cosmic neighborhood, but in the very dawn of galaxies. Here's your quirky tidbit. Black holes are surprisingly photogenic, at least indirectly. In 2019, the Event Horizon Telescope produced the first image of a black hole's shadow in galaxy M87, a glowing donut of plasma. JWST isn't built for that kind of close-up, but it reveals the neighborhoods black holes inhabit, jets of material stretching across thousands of light-years, glowing clouds of ionized gas, whole galaxies warped by their central monsters. In other words, Webb doesn't give us the mugshot, but it does capture the crime scene. As you peer through Webb's lens, you notice how galaxies with active black holes often look unsettled, like houses where something inside keeps slamming doors. Gas clouds are heated, star formation can be quenched, and matter is flung outward at ridiculous speeds. Yet black holes are not just destroyers. They shape galaxies, regulating growth, sometimes even triggering star formation in the shockwaves of their outbursts. They are cosmic editors, cutting and rearranging the story of galaxies themselves. And because you've promised yourself 3 light jokes per section, here they come. First, black holes are basically the universe's picky eaters, swallowing everything but spitting out just enough energy to ruin the neighborhood. Second, if galaxies are cities, then black holes are those landlords who never show up in person but somehow control everything. And third, you chuckle at the thought that humans spend fortunes building telescopes to see things defined by being unseeable. It's the ultimate hide-and-seek champion. You drift deeper into the thought of their paradoxical nature. Black holes cannot emit light, yet their very hemisphere hunger creates brilliance. They warp time itself, slowing clocks as you approach, stretching moments into infinity. Einstein's equations predicted such effects, and JWST's observations confirm the scale. You think about how stars wander too close, shredded into ribbons by tidal forces, their final screams visible across the universe. It's terrifying, but at this sleepy hour you find it oddly calming, like a reminder that some problems really are bigger than yours. You recall too how myths once filled the sky with hungry deities. The Norse spoke of wolves that devour the sun and moon. Hindu stories describe Rahu swallowing the sun during eclipses. To the ancient Chinese, celestial dragons ate the light. Now, instead of dragons, we talk about accretion disks and singularities, but the theme is the same. The heavens have places where light disappears, where power is absolute. Webb shows us the dragon's lair in sharp detail, golden scales of data shimmering in its images. Your imagination lingers on the jets, colossal streams of particles launched from near black holes at nearly the speed of light. Webb catches them in infrared, tracing their heat across intergalactic space. They look like cosmic searchlights, illuminating the dark. Entire galaxies can be sculpted by these jets, their gas reservoirs stripped or compressed. Their star-forming fates decided by invisible hands. It's as though black holes don't just sit at the centres of galaxies, they rule them. And then, the quiet thought drifts in. Our own Milky Way has one. Sagittarius A. A supermassive black hole, 4 million times the mass of the Sun, lurking 26,000 light-years away. It's calm compared to a quasar, but it's there, patient, a reminder that we live in a galaxy with a monster at its core. Webb hasn't turned its eye there yet in detail, but someday it might, peeling back more mysteries about the beast in our backyard. You let the image fade and you feel your own heartbeat slow. Black holes may be terrifying, but they are also steady, inevitable, woven into the fabric of the universe. They are proof that even in chaos there is order. Even in endings there is transformation. And as you drift in that realization, the darkness feels less like a threat and more like a lullaby, the deep, unblinking hum of gravity itself. The telescope's golden gaze lingers on those quasars and then turns inward, back toward a question that haunts every image. When exactly did the first light truly flicker on? Astronomers call this era the cosmic dawn, the time when the first stars and galaxies ignited after the long darkness that followed the Big Bang. JWST was built to pierce that veil, to find the moment when the universe stopped being a fog of hydrogen and helium and began to shine. You find yourself floating with the telescope at the threshold of this mystery, listening for the faintest whispers of beginnings. For decades, scientists agreed on a rough script: the Big Bang, then the Dark Ages, when the cosmos was too hot and opaque for light to travel freely. Then hundreds of millions of years later, the first stars switched on. These stars were supposed to be massive, short-lived, and made almost entirely of hydrogen and helium, the so-called population 3 stars. But Webb's early data hints that galaxies, and maybe even stars, appeared much earlier than expected. It's as though someone started the cosmic play before the audience found their seats. The mainstream fact here is clear. JWST has detected candidate galaxies at redshifts greater than 13, meaning their light began its journey when the universe was just 30 million years old. Some analyses even suggest possible galaxies at redshift 16 or beyond, barely 20 million years after the Big Bang. If confirmed, these would be the earliest galaxies ever seen, flickering on before theory says they should exist. The cosmic dawn seems not like a slow sunrise, but like lights flicking on in a rush, as if the universe couldn't wait to reveal itself. Historians still argue whether cosmology's great leaps happen because of technology or because of courage. Hubble gave us a timeline. Webb might force us to tear it up. Some astronomers whisper about exotic physics, dark matter behaving differently, or the rules of star formation being stranger than assumed. Others urge caution, reminding everyone how easy it is to misinterpret faint, stretched light. But you, hovering here in your drowsy imagination, feel the thrill of possibility. Maybe the universe has been holding back secrets, waiting for a sharper eye to uncover them. Here's your quirky tidbit. The first stars, those mythical population 3 giants, would have lived fast and died young, exploding within a few million years. Their deaths seeded the cosmos with heavier elements: carbon, oxygen, iron, the ingredients needed for life and planets. In a very real sense, we are the grandchildren of those first stars, and yet no telescope has ever seen one directly. JWST might be the first to catch their afterglow, hidden in faint galaxies or in the ashes of early supernovae. It's like waiting for a family album to reveal its very first ancestor. You imagine the universe at that dawn. The fog of hydrogen is clearing. Ultraviolet light from newborn stars is rionizing the cosmos, and suddenly illumination. Galaxies swarm like fireflies in a summer field. The darkness isn't erased all at once, but slowly pushed back, patch by patch, as the first cosmic neighborhoods light up. Webb's data suggests this happened much faster than predicted, as if the universe were impatient. Perhaps creation has always been a little hasty, and here come your 3 gentle jokes to soften the scale. First, you realize the dark ages of the universe lasted nearly 100 million years, basically the longest power outage in history. Second, the first stars were so massive they make our sun look like a candle at a bonfire, which feels like cosmic overcompensation. And third, you can't help but chuckle at astronomers calling them population 3 stars when we haven't even seen population 1 in their prime. It's like starting a movie at the third sequel and hoping to piece together the plot. Still, as you hover here, the questions pull you deeper. When did the first spark of structure appear? How did matter assemble so quickly into galaxies? Was dark matter the scaffolding that let gas fall into place faster than expected? Or is there something in physics itself we're missing? A hidden rule that reshaped the dawn? You hear the debates echoing faintly in the data streams, sharp voices softened by wonder. Ancient cultures would have loved this era. The Egyptians told of a cosmic egg cracking open to release the first light. The Norse imagined fire and ice colliding to birth the world. The Maya spoke of successive ages, each one kindled anew. JWST doesn't erase these myths. It provides their visual counterpart. The cosmic dawn is the scientific genesis, written not in scripture but in photons that travelled billions of years to reach us. And as you let that sink in, the telescope's stillness feels sacred. JWST doesn't rush. It waits, it watches, it collects. You imagine it like a monk copying ancient texts, one photon at a time, assembling a story that predates Earth itself. You, the sleepy witness, share in that patience, knowing you'll never see the whole picture but grateful for every fragment revealed. Perhaps that's the true gift of the cosmic dawn, not answers but perspective. That the universe has been awake far longer than we thought. That creation wasn't cautious, it was exuberant, rushing forward into brightness. You feel that rush ripple through you now, a reminder that beginnings are always messier and faster than we plan. And in that thought you drift, the first stars flickering like distant candles across the dark, keeping watch as you close your eyes. You linger at the threshold of cosmic dawn, but your thoughts bend now toward the unseen scaffolding of the universe, the strange symmetry of nothing. JWST shows you galaxies, stars, nebulae, even black holes, but what about the invisible hands that hold them all in place? Astronomers whisper about dark matter and dark energy, two forces that shape nearly everything yet reveal almost nothing. As you float beside the telescope, you realize you are surrounded not only by light but by mystery, by substances and energies that outweigh the visible cosmos but remain hidden, like stagehands in a play who never step into the spotlight. The mainstream fact is staggering. About 95% of the universe is invisible. Roughly 27% is dark matter, matter that does not emit or absorb light, detected only by its gravitational pull. About 68% is dark energy, an even stranger force pushing the universe to expand faster and faster. The stuff you can see, stars, planets, gas, everything Webb photographs, is barely 5%. It's as if you've been describing an orchestra by only listening to the triangle. Historians still argue whether the discovery of dark matter belongs to the Swiss astronomer Fritz Zwicky in the 1930s or to Vera Rubin in the 1970s. Zwicky noticed galaxies in clusters moving too fast, as if some unseen mass was binding them. Rubin later confirmed that galaxies rotate too quickly to hold together without hidden matter. Both were ridiculed at first, yet now their observations anchor cosmology. JWST doesn't see dark matter directly, but its images of lensed galaxies, light bent by massive halos of invisible substance, reveal its fingerprints everywhere. Here's your quirky tidbit. Some scientists jokingly call dark matter the broccoli of the universe. We know it's good for the cosmic diet, but nobody wants to actually deal with it. Despite decades of effort, no experiment on Earth has caught a dark matter particle in the act. It remains both obvious and elusive, like someone who always eats the last cookie but never leaves crumbs. You drift deeper into Webb's images, and gravitational lensing becomes a gentle spectacle. A massive galaxy cluster acts as a magnifying glass, bending and stretching light from more distant galaxies. Arcs and smudges curve around the cluster, cosmic funhouse mirrors created by invisible mass. JWST sharpens these distortions, letting astronomers map the distribution of dark matter. You realize the telescope isn't just showing you what's there, it's revealing what must be there, even if it hides. And then there's dark energy, the greater enigma. In 1998, astronomers discovered that the expansion of the universe is accelerating. Instead of slowing under gravity, galaxies are rushing apart faster and faster, as if some repulsive force fills space itself. JWST wasn't built to solve this mystery directly, but by mapping early galaxies, it refines our understanding of how cosmic expansion unfolded. Each image is a data point in a puzzle where the majority of pieces are invisible. To lighten the mood, here are your 3 gentle jokes. First, dark energy sounds like a villain in a superhero movie, but instead of fighting heroes, it just makes everything drift farther apart. Basically cosmic social distancing. Second, dark matter could be everywhere, even in your bedroom, but don't worry. It's shy and doesn't interact with you. And third, if 95% of the universe is invisible, then technically losing your keys is just participating in normal physics. Still you sense the weight of the mystery pressing softly on you. JWST's golden mirrors glitter with the visible 5%, but behind each image is the pull of the unseen. Without dark matter, galaxies would unravel, stars would drift away. Without dark energy, the universe's fate would be entirely different. These invisible players aren't extras, they're the main cast, and yet they refuse to step forward. You recall how ancient philosophers once spoke of hidden elements, ether, quintessence, the stuff between stuff. Maybe dark matter and dark energy are today's echoes of those intuitions, not the same but rhyming. The Greeks thought invisible spheres moved the stars, now we speak of invisible mass and energy. Both attempts remind you that human beings can't resist naming the unknown, even when we barely understand it. As you hover in that thought, the strangeness becomes strangely soothing. If most of reality is invisible, then maybe uncertainty isn't a flaw, it's the design. You don't need every answer before sleep, you just need to know that the questions are vast enough to hold you. JWST doesn't remove the mystery, it illuminates enough to deepen it. You sigh, feeling yourself float not just in space but in unknowing. Supported by the symmetry of something you cannot see, the telescope drifts quietly at L2, gathering photons as if knitting a blanket out of ancient light. But you realize the blanket has the holes, deliberate gaps where dark matter and dark energy hide. And maybe those gaps are part of the comfort. The universe doesn't tell you everything, but it tells you enough to keep you gazing, enough to keep you wondering. And as you let your eyes close, the invisible scaffolding holds you gently, a reminder that even the unseen can cradle you through the night. You float in that awareness of the unseen, but now JWST pulls your attention to something subtler, something neither entirely visible nor entirely hidden, cosmic dust. Not the dust on your bookshelf, though the principle isn't so different. This is stardust, tiny grains of carbon, silicon, and heavier elements forged in the deaths of stars. Dust clings to galaxies like fog, veiling their light, scattering it, reshaping how the cosmos looks to us. For generations, dust was astronomy's nuisance, a smudge on the lens. But Webb's infrared eyes transform it into a treasure. You begin to see dust not as a hindrance, but as a diary of starbirth, recording where suns have lived, died, and been reborn. The mainstream fact gestemsat here is that cosmic dust is essential. Without it, planets could never form. Dust grains are the seeds around which gas condenses, building pebbles, rocks, and eventually worlds. In your own solar system, Earth itself is the grandchild of dust clumps forged in ancient supernovae. JWST, tuned to the glow of infrared, can peer through the veils of dust clouds and reveal the galaxies, stars, and even planets gestating inside them. Where Hubble saw dark patches, Webb sees golden filigree, luminous webs threading across the black. Historians still argue whether dust has been unfairly maligned. Early astronomers called it an obstruction, an irritation that blocked their view of important things like stars. Only in the 20th century did scientists begin to appreciate dust as an active participant in the cosmic story. Vera Rubin once joked that dust was the astronomer's nemesis, yet today it's treated more like a character with its own voice, and Webb, more than any telescope before, has given dust its microphone. Here's your quirky tidbit. Some grains of interstellar dust that Webb studies are the same size as the particles you might find in cigarette smoke. Imagine that, tiny motes of ash floating not in your living room but between galaxies, carrying within them the history of exploding stars. Every time you brush a speck of dust off your desk, you could remind yourself that, on a grander scale, dust is the architect of everything. You hover deeper into Webb's portraits of dusty galaxies. In the Cartwheel Galaxy, dust forms intricate rings and arcs, glowing in colours invisible to your naked eye. In the pillars of creation, famous from Hubble, dust now glimmers with hidden stars poking through like fireflies behind curtains. You realize that dust is not a nuisance. It's a veil that, once pulled back, reveals the most intimate moments of creation. It hides the glare of young stars just enough for planets to coalesce safely in the shadows. In this way, dust is both guardian and archivist, protecting fragile beginnings and recording cosmic history grain by grain. And yes, the three gentle jokes drift in on the cosmic breeze. First, dust in space may be poetic, but it still triggers the same instinct: you want to sneeze. Second, if dust is the building block of planets, then technically every time you vacuum you're reenacting planetary formation, just less gloriously. And third, astronomers once cursed dust for ruining their images. Now they dedicate billion-dollar telescopes to studying it. Talk about a cosmic redemption arc. You think too about how dust connects you personally to the stars. Every element heavier than helium in your body, carbon in your cells, iron in your blood, calcium in your bones, was once part of dust clouds enriched by dead stars. JWST's glowing maps of dust aren't just pretty, they are portraits of your ancestry. You are looking at the factories of everything you are made of, and that realization wraps around you like a soft blanket, as though the cosmos itself is tucking you in. Ancient cultures had their own ways of describing this connection. In Mesopotamian myths, humans were said to be formed from clay mixed with divine breath. In the Bible, Adam is shaped from dust of the ground. In Hindu traditions, the god Vishnu dreams the universe into being from the substance of his body. You can't help but smile at how close those stories came. We are indeed dust come alive, breathing, dreaming, and Webb's images are simply the newest verses of that old song. You linger on a particular image, a starburst galaxy where dust glows like embers in a cosmic fireplace. You imagine leaning closer, feeling the warmth of creation itself. Of course, in reality, it's minus hundreds of degrees Celsius, but in your sleepy mind, it radiates comfort. You understand now why astronomers are so excited about dust. It is the breadcrumb trail leading back to the first stars, the record keeper of the universe's most intimate secrets. And as you let that realization settle, the telescope's hum feels quieter, softer. JWST is not just a machine of discovery, it's a patient dust collector, sweeping up the faint motes that tell the story of everything. You drift in that thought, cozy in the idea that dust is not an inconvenience but a lullaby, scattered across the cosmos, carrying you gently toward dreams. You float with the telescope still, and as the hum of data streams lulls you, the story begins to bend, not toward numbers or spectra, but toward memory, imagination, myth. For all the science JWST delivers, you realize it is also a mirror to the oldest human impulse, to tell stories about the sky. Ancient cultures looked upward and filled the darkness with gods, monsters, and creation myths. Now, with Webb, we look upward again and fill it with galaxies, quasars, and redshifts. Different language, same hunger. The mainstream fact grounding you here is simple. Every culture on Earth has a cosmology. From the Norse tales of Ymir's body becoming the world, to the Chinese myth of Pangu cracking open the cosmic egg, to the Aboriginal Dreamtime stories where the Milky Way is a river of ancestral spirits. These weren't primitive guesses, they were frameworks, attempts to explain the night sky in ways that gave meaning. And you see how JWST's images, breathtaking and strange, are reshaping our own shared mythology of beginnings. Historians still argue whether modern science has replaced myth or simply created a new one. After all, when you describe a golden telescope unfolding in space, catching whispers of the first stars, doesn't it sound mythic already? Engineers become demigods of precision, photons become ancient messengers, the cosmos itself becomes an oracle whispering secrets. Perhaps Webb isn't ending myth, it's adding another verse. Here's your quirky tidbit. The very word cosmos comes from the Greek kosmos, meaning both order and ornament. The night sky was never just practical, it was decoration, a jeweled tapestry. And when you look at Webb's mosaics of galaxies, their spirals and arcs and clusters, you see that sense of ornament renewed. It's not only data, it's art. You let your mind drift between myths and images. The Carina Nebula's towering cliffs could easily be read as the mountains where gods dwell. The cosmic dawn could be the first candle lit in the temple of creation. Even black holes could play the role of mythic devourers, swallowing stars like serpents consuming the sun. JWST doesn't erase these metaphors, it invites them to coexist with equations. The numbers explain how, the myths explain why. And now, your 3 gentle jokes arrive like little fireflies. First, if ancient cultures saw the Milky Way as spilled milk, then JWST's images must look like the universe dropped its entire grocery cart. Second, one day textbooks might describe Webb's launch in the same tone myths describe the gods flinging stars, except ours begins with, "So NASA built a telescope for $10 billion. And third, you can't help but grin at the thought that in 1,000 years, JWST might itself be remembered as myth, the golden eye that opened the heavens. You pause, remembering how humanity has always marked sacred places to observe the skies. Stonehenge in England, Chichen Itza in Mexico, the Jantar Mantar in India, all monumental observatories. JWST is simply the latest, but instead of stone or brick, it's gold and beryllium. Instead of aligning with the sun on solstices, it aligns with light from galaxies 13 billion years gone. And yet the impulse feels identical. To watch, to measure, to belong to the cosmos. You drift softer now, the telescope itself shimmering in your imagination as something holy, a relic of a species that wanted to know where it came from. And suddenly the myths and science blur together. You see Orion not only as a nebula but as a hunter. You see galaxies not only as masses of stars but as jeweled necklaces. You see black holes not only as equations but as cosmic dragons. Both stories comfort you, one with facts, the other with symbols. Your breath slows. You feel the myths weave with the hum of photons, wrapping around you like a quilt stitched from starlight and legend. The telescope whispers, but so do the ancestors, and their voices harmonize. You realize that sleep itself is a kind of myth-making, slipping into a world of symbols where reality and dream fold together. Webb doesn't end that story. It deepens it, adds more detail to the lullabies we've always sung about the night. And so in this moment, the science fades into something softer. You imagine the telescope less as a machine and more as a storyteller, turning galaxies into bedtime tales. Each image is both a data set and a dream, both a spectrum and a myth. You feel that duality cradle you, rocking you gently. Myth and science, order and ornament, explanation and wonder, they are not rivals. They are twin constellations shining above you as your eyes begin to close. The myths fade softly into starlight, and soon your gaze is drawn to the ashes of stars long gone. JWST does not only peer at the births of suns and galaxies, it also lingers on their endings, on the luminous shrouds left behind when stars explode. Nebulae like the southern ring, or the crab glow in Webb's images as intricate filigree, gas and dust sculpted into delicate layers, glowing faintly from the energy of dying stars. These are not graves so much as gardens, places where death becomes dazzlingly beautiful. You drift closer, tracing the curling tendrils of gas that stretch across light years, shimmering like embers on the surface of eternity. The mainstream fact grounding you here is straightforward. When stars much more massive than the sun reach the end of their lives, they explode as supernovae. The blast scatters heavy elements into space, enriching the cosmos with oxygen. Carbon, iron, the very elements needed for 4 planets and life. Our bodies contain atoms forged in these explosions billions of years ago. Every breath you take carries oxygen born in the heart of a dying star. To watch a nebula through Webb's golden mirrors is to look at your own ancestry. Historians still argue whether the supernova of 1054, observed by the Chinese and Middle Eastern astronomers, was the most influential stellar explosion in recorded history. It was so bright it was visible in daylight for weeks. Today its remnant is the Crab Nebula, a chaotic lattice of glowing filaments that Webb reveals in exquisite infrared detail. Imagine seeing a new star appear in the daytime sky and not knowing why. How terrifying and wondrous that must have been. For those ancient sky watchers, it wasn't just astronomy, it was a sign from heaven. Here's your quirky tidbit. The Southern Ring Nebula, one of Webb's first public images, revealed something unexpected. Astronomers knew it housed a dying star, but Webb's infrared vision exposed a second star hidden inside the cloud, a quiet partner in the drama. The image showed shells of gas layered around them like concentric ripples from a stone tossed into a pond. In other words, even in death, stars can surprise us with company. You linger on those shells of gas, each layer marking an outburst as the star shed its outer skin. It looks almost ceremonial, as if the star were carefully undressing before fading into the night. And yet, there's no dignity here, just physics. Fusion sputtering, gravity collapsing, radiation tearing layers away. The beauty is ours, the meaning is ours. The star itself simply ended, leaving behind the raw material for new worlds. And your 3 gentle jokes arrive to soften the sorrow. First, if stars really are going out with a bang, then supernovae are the universe's loudest retirement parties. Second, nebulae look delicate in photos, but in reality they're stellar confetti tossed across light years. And third, if humans turn into dust when they die, stars take it a step further. They turn into all the dust. You think about how these nebulae look like stained glass windows glowing in a cosmic cathedral. The gases form blues, reds, and golds, patterns both chaotic and symmetrical. Webb, with its infrared palette, deepens the colours until they feel almost painterly. You imagine walking through the halls of space and finding these glowing windows floating in the dark, each one telling the story of a star that once burned, lived, and died. Cultures long ago may not have known about fusion or nucleosynthesis, but they sensed the cycle. The Egyptians believed in Ra dying each evening and being reborn at dawn. The Norse saw Ragnarok not as an end, but as a renewal. In Hindu cosmology, Shiva both destroys and creates, and here in Webb's images, you see that same pattern written in gas and dust. Stars die, but their death feeds life. Endings are beginnings. You let your eyes soften. You imagine drifting into the Southern Ring Nebula itself, floating through its glowing layers. Light shimmers around you, filtered by hydrogen, oxygen, and carbon. In the centre, a white dwarf glows faintly, the last ember of a star once grand. It pulses like a dying heartbeat, steady but fading. You understand now why Webb's images of these nebulae move so many to tears. They're not just scientific, they're human. They remind us that beauty and death are not opposites. And so you breathe, slowly, gently, as the filigree of gas unfurls around you. The telescope has shown you nebulae not as dusty leftovers, but as luminous art, crafted by physics, yet interpreted by awe. You realise that one day the sun will do the same, casting off its outer layers, leaving behind a glowing nebula that future telescopes, future dreamers, might admire. Your own star will become someone else's lullaby. The thought is both melancholy and comforting, a perfect paradox for sleep. You are stardust, yes, but you are also starlight, brief and brilliant. And as you drift through the glowing remnants of suns, you feel yourself part of that endless cycle, burning, fading, scattering, beginning again. The glowing remnants fade behind you, and now your awareness sharpens to the strangest truth of all. Every photograph from JWST is also a time machine. What you see is never now. Each image is a letter mailed across billions of years, arriving long after its author has vanished. To look at a distant galaxy through Webb is to witness its childhood while, in reality, it may have long since grown old or even dissolved. The telescope doesn't just see space, it sees time. You float in that realization, rocked gently by the idea that the universe is a scrapbook, and light is the glue that holds its pages together. The mainstream fact grounding you is that light takes time to travel. The sun's light takes 8 minutes to reach Earth, which means every sunrise is already 8 minutes old. For the nearest star beyond the sun, Proxima Centauri, the delay is 4 years. For the most distant galaxies Webb has captured, the delay is more than 13 billion years. You're not looking out, you're looking back, peering across time like a historian flipping fragile parchment. Historians still argue whether this quality of astronomy, its ability to reveal the past but never the present, makes it more like science or archaeology. After all, archaeologists study ruins to reconstruct ancient lives. Astronomers study light to reconstruct cosmic history. Both fields rely on fragments. Both invent narratives. Both accept that their vision will always be incomplete. Webb is the newest archaeologist, since its tools not brushes and trowels but mirrors and detectors. Here's your quirky tidbit. When you look at the Andromeda galaxy with the naked eye, you're seeing it as it was 2.5 million years ago. That means your current view of Andromeda predates humans as we know them. The galaxy you see tonight is older than your species. And Webb, stretching its reach billions of light years farther, shows you things no human context can contain. It's like opening an old family album and finding photos from before your family even existed. You hover close to Webb as its golden mirrors drink in faint photons, and you realize the telescope itself is a kind of postal worker. Every photon it catches is a postcard written in starlight. Wish you were here 12 billion years ago. Some postcards show galaxies thriving, others show them colliding or collapsing. The senders never expected you to read them, but here you are, late-night dreamer, holding their messages against your chest, and 3 gentle jokes, because even time travel needs a smile. First, if light is always late, then technically the universe is the world's worst pen pal. Second, when you look at yourself in a mirror, you're technically younger by a few nanoseconds, so congratulations, you found the fountain of youth. Third, Webb is the only machine that makes procrastination noble. What's 13 billion years between friends? Still, the awe returns quickly. You remember the famous Hubble Deep Field, taken in the 90s, when astronomers pointed the telescope at what seemed like an empty patch of sky and found thousands of galaxies hiding there. JWST's deep fields repeat the trick but go further, pulling galaxies from even earlier epochs. What looked like nothing becomes everything. What looked like blank space becomes a cosmic diary. The realization settles in you like a lullaby. Time itself is not linear here. The deeper you look, the farther back you go, until the present dissolves into the past. JWST makes you a traveller without moving, a witness without leaving your chair. It collapses the gap between ancient light and modern eyes, between what was and what is. You think of ancient myths again, of gods stepping outside time, of oracles seeing past and future together. Webb doesn't need prophecy, it needs photons. Yet the effect is the same, a vision beyond the ordinary, a glimpse into epochs no human imagination had touched before. The telescope is both oracle and archive, speaking the language of light. And then you wonder about the other side of this exchange. If another civilization far away had a telescope like Webb and turned it toward Earth, what would they see? Not you, not now, but perhaps the Earth of dinosaurs, or the Earth of mammoths, or maybe just a glowing cradle of molten rock. To them, you do not exist yet. To them, Earth is still a dream. The thought is dizzying and strangely comforting. You're both ancient and unborn, depending on where the eye is placed. You breathe slowly, letting the paradox soothe you. JWST's time machine vision isn't about paradoxes, it's about perspective. You are a creature bound to the present, yet your eyes can hold the past. Every star you see tonight is a memory, every galaxy a history book, and Webb is the library card, granting you access to shelves stacked higher than imagination. The telescope hums on in its cold perch at L2, catching more postcards from the past. You picture yourself slipping them into an album, flipping through pages filled with glowing smudges and spirals. Each one is both gone and alive, both past and present, and you, drifting at the edge of sleep, are the reader who makes them matter again. The postcards from the past fade into your imagination, and JWST now tilts its golden gaze toward the strangest forecasts of all, alien weather reports. You thought Earth was dramatic with its hurricanes and heat waves, but exoplanets write their meteorology in wilder ink. With its sensitive instruments, Webb detects not only gases, but the motion of those gases, the layering of clouds, the rise and fall of alien winds. Suddenly, worlds light years away don't just exist in theory. They have seasons, storms, and skies you can almost taste. The mainstream fact is this. In late 22, JWST turned its instruments on the hot Jupiter WASP-39b, a bloated gas giant orbiting close to its star. The data revealed water vapor, carbon dioxide, sulfur dioxide, and evidence of photochemical reactions. Basically smog, but interstellar. This was the first clear detection of such chemistry outside our solar system. Think about that. A planet so far away you'd need millennia to reach it. And yet Webb can tell you its skies are hazy. It's the closest thing humanity has to sticking a weather balloon in another star system. Historians still argue whether our fascination with weather is survival instinct or storytelling. Farmers tracked the skies to predict crops. Sailors read clouds to survive voyages. Poets wrote of storms as omens. Now, astronomers pass starlight for similar signs, only instead of tomorrow's rain, they're predicting metal clouds and 1,000-mile-per-hour winds. Weather has always been a bridge between the human and the cosmic. JWST simply stretches that bridge farther than ever before. Here's your quirky tidbit. Some exoplanets have such extreme conditions that it literally rains glass. Tiny silicate particles condense in high winds, forming shards that cut sideways across the atmosphere at supersonic speeds. Another planet likely rains liquid iron, droplets sizzling as they fall into molten oceans. If you ever complained about Earth's weather, remember, at least you don't need an umbrella made of titanium. You drift deeper into Webb's exoplanet catalogue. On WASP 121b, evidence suggests clouds of metal vapour forming in the upper atmosphere, glowing faintly with heat. On Kepler 7b, reflective clouds scatter starlight, giving the world a ghostly shimmer. The telescope's instruments capture subtle changes in brightness as planets move in front of or behind their stars, teasing out patterns that reveal not just composition, but circulation. You imagine the telescope as a weatherman pointing at a galactic green screen. And over here, we've got storms of molten quartz, while further east, metal fog is expected to settle in the afternoon, and 3 gentle jokes drift in with the cosmic breeze. First, Earth weather reporters get grumpy if the 7-day forecast is off. Webb is forecasting light years away. Beat that, meteorologists. Second, if an alien civilization tunes into our broadcasts, they might think we're boring. Rain again? Where's the lava rain? And third, you wonder if umbrellas sold on exoplanets come with labels like heat resistant to 2000 degrees. Still, the humour fades into awe. These atmospheric readings matter because they're stepping stones to life detection. Clouds of methane or oxygen balanced in strange ways could signal biological processes. On Earth, photosynthesis and respiration sculpt the atmosphere. If Webb finds a planet with chemical fingerprints that don't add up naturally, the implication will ripple across every culture on Earth. Not just weather, but life, hidden in the haze of an alien sky. You picture yourself standing on one of these worlds. The horizon glows with alien twilight. Skies streaked in colours your eyes have no names for. Winds scream at hundreds of kilometres per hour, tearing clouds into ribbons. Maybe the rain falls as metal beads, tinkling softly as they strike the ground. You're not really there, but Webb has made it imaginable, and that alone feels like magic. Ancient peoples once read omens in the weather, thunder as divine anger, rainbows as promises, eclipses as warnings. We still personify the skies in our stories. Now JWST adds alien storms to that tradition. If you squint at its spectra, you can almost hear a myth forming. A planet where the sky rains blades, a world of fire winds, a place where smog itself glows with starlight. Science births myth, myth births awe, and awe births wonder. You let your breathing slow, picturing the telescope quietly passing its starlit rainbows, translating alien storms into gentle graphs. It is patient, impartial, never dazzled by the drama of weather. But you, floating beside it, feel the hush of alien winds in your ears. The universe is no longer a cold void, it is alive with tempest skies and seasons. And in that realization you find comfort. Even worlds you will never walk on have weather, and weather in its way is home, so the alien storms quiet in your mind, and JWST now draws your focus to another of its eerie talents, watching the universe bend under its own weight. Gravitational lensing, predicted by Einstein more than a century ago, is not just a curiosity, it is one of Webb's favourite tricks. Light from distant galaxies travels toward us in straight lines, but if it passes near something massive, like a galaxy cluster, space-time itself curves and the light bends. The result is cosmic glasswork, arcs, smears, and magnified echoes of galaxies otherwise too faint to see. You float in front of Webb's images and feel like you've stepped into a hall of mirrors designed by the universe. The mainstream fact here is this: gravitational lensing lets astronomers see farther than any telescope could alone. By using clusters of galaxies as natural telescopes, Webb magnifies background objects up to 100 times. Some of the earliest galaxies we know of were spotted this way, tiny sparks magnified into view by cosmic coincidence. Without lensing, they'd remain invisible, their light too faint to touch even Webb's golden mirrors. Historians still argue whether Einstein truly believed his prediction about bending light would ever be tested. In 1919, during a solar eclipse, Arthur Eddington measured starlight deflected by the sun's gravity, proving relativity to the world. Newspapers declared, Lights all askew in the heavens. Now, a century later, Webb shows us that the heavens are always askew, their light curving around invisible masses. Relativity isn't an oddity, it's the architecture of the cosmos. Here's your quirky tidbit. Some gravitational lenses produce what astronomers call Einstein rings. Perfect circles of light formed when a background galaxy aligns just right with a foreground mass. They look like glowing cosmic donuts. Webb has already captured several delicate rings shimmering around massive galaxies. Imagine stumbling across a necklace of light, forged not by hands but by gravity itself. You drift into Webb's deep field images, tracing the arcs of distorted galaxies. Some look stretched, like taffy pulled by invisible fingers. Others appear multiple times, their light split into duplicate images by the lensing effect. You marvel at the irony. The universe itself becomes a telescope, bending its own rules to let us see deeper. Webb doesn't just look at galaxies, it recruits galaxies to help it see. And here are your 3 gentle jokes, sprinkled like stars. First, gravitational lensing is basically the universe photobombing itself. Second, Einstein rings might be beautiful, but they don't make terrible hula hoops. And third, if you squint, lensed galaxies look like cosmic smiley faces, proof that even the universe loves a good selfie. Still, beneath the playfulness awe presses in. These distortions aren't flaws, they're clues. By studying the shapes and positions of lensed arcs, astronomers can map the invisible distribution of dark matter in galaxy clusters. It's like using the ripples on a pond's surface to infer the rocks hidden beneath. Webb turns warped light into a cartography of the unseen, showing us mass we cannot otherwise detect. You imagine ancient skywatchers seeing bent starlight and weaving myths about trickster gods twisting the heavens. In a sense, they wouldn't be wrong, the cosmos is indeed warped, though by physics rather than mischief. Yet the wonder feels the same. The realization that the sky is not fixed but elastic, bending and shifting under unseen forces. Webb's images capture this elasticity in exquisite clarity. In some, faint galaxies appear magnified into delicate crescents, tiny structures revealed in detail that would otherwise take impossibly large telescopes to resolve. You realize lensing is not just a scientific tool, but a kind of cosmic generosity. The universe hides its treasures, but then, through gravity, lends us a magnifying glass to find them. And as you let that thought soften you, the distortion itself begins to feel soothing. Light bends, time stretches, galaxies repeat, and yet there is order. Relativity doesn't break the rules, it writes them anew. You close your eyes and imagine drifting through one of those Einstein rings, a circle of light surrounding you like a halo. For a moment, you feel less like a spectator and more like part of the cosmic glasswork, woven into the lens itself. The lensed halos fade from your mind, but the questions they raise remain heavy, pressing at your temples like the pull of distant gravity. JWST has shown you galaxies too early, black holes too massive, stars too hurried, and dust too luminous. Everywhere you look, the telescope returns puzzles bigger than the answers we hoped for. The universe is not a polite student sticking to the syllabus, it's a trickster professor, dropping paradoxes like pop quizzes. You float beside the telescope, wondering if knowledge is less about neat solutions and more about learning to live with contradictions. The mainstream fact grounding you hear is that Webb has already challenged models of galaxy formation and cosmic expansion. Galaxies appear to have assembled faster than expected. Black holes ballooned earlier than equations allowed. Some spectra hint at chemical complexity in times when the universe should have been too young for such richness. These aren't small tweaks. They are cracks running through the foundation of our cosmological models. Historians still argue whether great scientific revolutions arrive as sudden breaks or gradual shifts. Copernicus moved Earth from the centre of the universe, but it took generations for the worldview to settle. Darwin proposed evolution, but the debates never fully quieted. Maybe Webb is ushering in a similar transition, a moment when theories creak under new evidence, and the next paradigm waits just beyond our imagination. Here's your quirky tidbit. Some astronomers jokingly call JWST the theory buster. Others, with equal humour and anxiety, call it the job creator, since every puzzling result spawns a dozen new PhD dissertations. It's a reminder that confusion is not failure, it's fuel. Science thrives on questions that refuse to sit still. You hover closer to the telescope, listening as its detectors hum. The contradictions echo in your own head. If galaxies are too old, maybe our clocks are wrong. If black holes grew too fast, maybe gravity behaves differently in the early universe. If the chemistry is too advanced, maybe stars forged elements more efficiently than we thought. Each possibility is thrilling and terrifying. You feel the cosmos wink at you. You thought you knew me, try again. And because you've promised yourself 3 gentle jokes, here they come. First, the universe is basically that friend who promises a chill evening, but turns it into a 3-hour existential debate. Second, cosmologists have started whispering back to the drawing board, which sounds noble, but mostly means coffee budget doubling. Third, you can't help but laugh at the thought that we built the most advanced telescope ever, only to discover that the universe has been trolling us for 13 billion years. Still, beneath the laughter is awe. You remember that contradictions are not the end, they are the beginning. When Newton's laws couldn't explain Mercury's orbit, Einstein's relativity was born. When particles didn't fit neatly, quantum mechanics emerged. Maybe Webb's paradoxes are seeds of the next revolution. The telescope isn't mocking us, it's nudging us forward, insisting we grow. You think of ancient philosophers again, of Heraclitus saying the cosmos hides its nature through habit. Perhaps the habit now is surprise. Perhaps the contradictions are the cosmos's way of reminding us that humility is part of knowledge. To study the stars is to accept that answers will always be incomplete, that the horizon will always recede. You let the thoughts soften you. The puzzles no longer feel like taunts, but like lullabies sung in riddles. Galaxies too old, black holes too fast, dust too bright. Each one is a cosmic koan, a paradox meant not to frustrate but to awaken. You realise the universe has always been bigger than our equations, and maybe that's the comfort. If it were simple, it wouldn't be worth staying up to dream about. The telescope drifts silently at questions piling in its data like snowflakes. You imagine scientists shoveling through them, muttering, laughing, gasping, but you here now don't need the answers, you only need the wonder. Contradictions can cradle you too, rocking you gently with their unresolved rhythm. And as you close your eyes, the universe itself feels like a question mark drawn in stars, curving across the night, inviting you to dream inside its curve. The riddles of the cosmos hum softly in your thoughts, but now a sharper question rises, the one that has haunted every stargazer from ancient temples to modern observatories. What if we are not alone? JWST, with its spectral sniffing and golden gaze, edges closer to this mystery than any instrument before it. Each atmosphere it studies, each chemical fingerprint it decodes is a chance, however slim, for life to wave at us across the void. You float beside the telescope, imagining the weight of that possibility, to discover that Earth is not the sole cradle of consciousness, that our loneliness is an illusion. The mainstream fact grounding you here is that Webb has already detected key molecules, water vapor, methane, carbon dioxide, on distant exoplanets. These aren't proof of life, but they are the ingredients, the raw notes in a cosmic recipe book. Scientists talk about biosignatures, combinations of gases that on Earth only life can sustain. For instance, oxygen and methane together would be suspicious. They react quickly, so their simultaneous presence would suggest something is constantly replenishing them. Webb has the precision to look for such balances, to ask if chemistry itself is whispering, "I am alive." Historians still argue whether we should even be searching. Some say the discovery of alien life would be the most profound shift in human history, rewriting religion, philosophy, even some politics. Others say the silence we've encountered so far, the Fermi paradox, might be a warning. If advanced civilizations existed, why don't we see evidence of them? Perhaps they've vanished. Perhaps they're hiding. Or perhaps, more unsettling still, we are early, the first to wake in a still sleeping universe. Here's your quirky tidbit. In 2023, Webb analysed the atmosphere of KT-18b, a super-Earth, orbiting in its star's habitable zone. Some scientists thought they saw hints of dimethyl sulfide, a molecule that on Earth is produced by phytoplankton. The evidence wasn't conclusive, but for a moment headlines shouted, "Life?" The community quickly calmed the excitement, but the fact remains, JWST may have glimpsed the first chemical footprint of biology beyond Earth. Even a whisper was enough to make the world lean forward. You drift deeper into this thought and imagine what it would feel like if Webb confirmed such a biosignature. Press conferences would erupt, social media would combust, children would grow up knowing we are not alone. Perhaps some would feel fear, others joy. Religions might interpret it as divine affirmation or as challenge. Philosophers would debate whether life elsewhere makes us special or ordinary, and you, floating here in your sleepy imagination, would feel a shiver of connection, as if your tiny life was suddenly threaded into a vast, unseen community. And your three gentle jokes arrive like comets to ease the tension. First, if alien microbes exist, they're probably laughing at us for spending $10 billion just to smell their farts. Second, if we do make contact, hopefully it isn't during rush hour. Earth's traffic would be a terrible first impression. And third, if we ever meet aliens, I bet they'll be annoyed at being called little green men. They'll probably say, actually, we're tall purple fungi, thank you very much. Still, beneath the humour, the yearning deepens. You realise that even the act of searching is meaningful. To point a telescope toward alien skies is to admit that loneliness is unbearable, that curiosity is stronger than fear. Webb doesn't just collect spectra, it holds a mirror to our desire for kinship. Every chart, every faint line in a spectrum is humanity whispering into the dark. Are you there? Ancient myths already imagined this possibility. The Dogon of Mali spoke of companions to Sirius long before telescopes confirmed them. The Greeks peopled the heavens with gods who watched and meddled. The Maori described star ancestors guiding their descendants. Perhaps the idea of others in the sky is as old as humanity itself. Webb simply sharpens the vision, offering data instead of myth, but the longing remains the same. You let your breath slow as you consider the silence. Maybe Webb will find biosignatures tomorrow, maybe never. But the very fact that we are asking proves something extraordinary, that a species of apes, on a small planet circling a mediocre star, built a golden mirror to look for neighbours in the cosmos. That act alone is a declaration. We do not want to be alone. And as your eyes grow heavy, you realise the silence itself has a lullaby quality. Either life waits out there, or we are the universe's first dreamers. Both are awe-inspiring, both are worth whispering to. And as Webb hums quietly at L2, you feel yourself part of that whisper, drifting into sleep with the thought that maybe, just maybe, somewhere someone is drifting too, wondering if they are alone. The question of loneliness lingers, but slowly your perspective shifts, softening as you realise that every Webb image, every spectrum, every glowing smudge is also a reflection of us. The telescope may look outward, but in doing so it reveals inward truths, our fragility, our hunger for meaning, our endless audacity. You float beside the golden mirror, and for a moment it feels less like a machine and more like a looking glass, showing not just galaxies, but humanity itself. The mainstream fact grounding you here is that JWST is the most ambitious international science project ever launched, built by NASA with contributions from the European and Canadian space agencies. Thousands of engineers, scientists and technicians across continents poured decades of work into it. It is, in a real sense, a monument not to one nation, but to humanity's collective curiosity. When you gaze at Webb's images, you're not just seeing the universe, you're seeing the proof that people can cooperate across borders, languages, and generations for the sake of wonder. Historians still argue whether space exploration is primarily about politics, prestige, or science. The Apollo missions were driven by Cold War competition as much as by curiosity. Webb 2 was born amid budgets and bureaucracy, delays and doubts. Yet once it unfurled and began sending back its images, the debates quieted. For a brief moment, the world collectively gasped. Children in classrooms, retirees in nursing homes, presidents and poets all stared at the same galaxies. The telescope stitched us into a single audience, watching the same ancient light. Here's your quirky tidbit. Webb's mirrors are polished so precisely that if one was stretched to the size of North America, the largest bump would be less than the height of a ladybug. That kind of obsessive craftsmanship is why the telescope works, and it's also why in some sense it reflects us, not as perfect beings, but as beings who can aim for perfection when the goal is big enough. You drift closer, watching the golden segments glow faintly in the starlight. Each one was built separately, shipped across oceans, assembled like a puzzle in a clean room, tested for years, then folded into a rocket fairing. Now they rest in silence a million miles away, aligned with microscopic precision. The journey feels almost human. Fragile parts coming together, surviving trials, unfolding into wholeness. You wonder if Webb's story is really our story, a metaphor for what we could be if we chose to align ourselves with the same care. and your 3 gentle jokes arrive, softened with sleepiness. First, Webb is basically humanity's best selfie stick holding up a mirror to the cosmos. Second, if aliens ever find it, they'll probably wonder why we launched a giant golden waffle into space. And third, given how many things had to go right, the telescope itself is proof that miracles sometimes wear lab coats. Still, the humour fades into reflection. You realise that Webb's images don't just show stars and galaxies. They show us reaching. They show a species that refuses to be bound by its cradle, that builds machines to pierce the dark, that insists on asking questions even when answers are scarce. Every arc of light, every smudge of dust, every spectrum is a love letter to curiosity. Ancient myths told of mirrors that revealed truths, of pools where gods or spirits showed visions. Webb is our modern mirror, revealing not divine secrets but cosmic realities. Yet the effect is similar. It humbles, it awes, it makes us small and vast at once. To look into Webb's eye is to see both the universe and yourself woven into its fabric. You breathe slowly, letting the thoughts settle. The telescope will last perhaps for decades. It will outlive some of us, outshine our daily worries, and continue gazing into the deep. But its real legacy isn't the data, it's the wonder. It's the reminder that even in chaos, humanity can pause, build something beautiful, and hold it up to the stars. And so as you drift at the edge of sleep, you imagine the telescope gazing not only outward, but back at Earth, at us, at you. It doesn't judge, it simply reflects. Fragile, flawed, ambitious, ridiculous. You're all of it, we're all of it. And in that reflection, we see ourselves not as separate from the universe, but as part of its endless story, stardust daring to look back at the stars. The telescope fades from view, and the pace of your thoughts slows. The galaxies, the storms, the myths, all recede into a gentle glow, like lanterns drifting away on a quiet river. Your breathing deepens, you let the dark cradle you. The questions remain, about beginnings, endings, and what lies between, but they no longer press for answers. They settle softly like dust on a windowsill waiting for another night. You understand now that mystery is not a burden, it is a lullaby. Imagine the telescope still at L2, golden petals open, drifting in silence. It continues its vigil, gathering photons that began their journeys before Earth was born. Somewhere, at this very moment, new light is arriving in its mirrors, faint, fragile, carrying stories yet untold. You don't need to hold them now, you only need to know they're there, waiting. Feel your body sink a little deeper. The hum of data becomes a background song. The arcs of galaxies blur into the curves of your dreams, the stormy skies of exoplanets, the fiery cradles of nebulae, the whisper of dust. They all soften, fading into a single rhythm, slow and steady. You are small, yes, but also vast. You are fragile, yes, but also timeless. You are not separate from the cosmos. You are its child, its witness, its dreamer. And tonight, as your eyes close, you are also its sleeper. Let the universe hold you now. Let Webb's golden mirrors reflect you back into quiet. Drift gently, deeper, into the dark that is not emptiness but embrace. The stars are still there, the questions are still there, and they will wait until morning